Right, question 5 is a question about functions, composite functions, inverse functions. Um, wasn't too bad. Well, I say that. Um, the first part wasn't too bad. It fell apart a little bit after that. So, anyway, let's get into it. So, we've got to first of all find FG of 4. So, let's write down some question numbers. By the way, writing down the question part numbers is important because markers are only supposed to mark the work which is in the correct part of the question. So if you don't label your work, they don't have to mark it. So the first thing we want FG of 4, which we can interpret as F of G of 4. Okay, so the first thing we need is G of 4. So G of 4 is 2 plus 3 lots of 4 minus 4 squared, which is 2 plus 12 minus 16, which is negative 2. Then we want to plug that into F. So F of minus 2. So FG of 4 is the same thing as F of minus 2, which is K times minus 2 over 2 times minus 2 minus 1, which is minus 2K. And that is minus 4 minus 1, which is minus 5. There was at least one person who left their answer like that, but for goodness sake, multiply top and bottom by minus 1 to knock out those negatives. So the answer is 2K over 5. Okay. Now, part 2, this was tricky, the range of F. This is the one question where I sort of feel this is slightly outside of the scope of the A-level specification because we don't teach rational functions as a topic, and this function f of x is what's called a rational function, where you've got a polynomial over another polynomial. But with a little bit of thought, it's not too difficult to try and work out what this function looks like. If you have a graphical calculator, of course, you can help yourself here by plugging in the function. You'd have to invent a value of k in order to do so. It just says k is non-zero, so I suppose k could be positive or negative. But just to quickly go through how you might do this, when you have a linear function over another linear function, so if you've got something like, ax plus b over cx plus d, it's going to be some sort of reciprocal function like a 1 over x graph, but it's going to have different asymptotes. Okay, so it's going to sort of come down here and come do this sort of thing. Okay. Um, the trick is working out where the asymptotes are going to be. The vertical asymptote comes from the denominator being 0, and the horizontal asymptote comes from considering either very large positive or very large negative values of x and thinking what would the effect of that be. So in this particular question, we've got f of x is kx over 2x minus 1. And we're already told that x is not equal to a half. Okay, that's because x equals a half gives us a 0 on the denominator. So that's where our vertical asymptote is going to be. It's going to be at x equals a half. I'll come back to that later because it's really important. This is the domain of the function, and to have a properly defined function, you always give the equation of the function, but you also give the domain. This will be important later. So we need to also think about what's going to happen. So it's going to be some sort of reciprocal function. The other thing to consider is what happens as x tends to infinity. Okay, so as x tends to infinity, or in other words, what would happen for very, very large x? And what would happen is that f of x tends towards, now kx, obviously, if x is very large, kx is a very important term. But on the denominator, 2x minus 1 the minus 1 is not important, because if x is a million, 2 million minus 1 is pretty much the same as 2 million. There's very little difference. I'm just going to put a little minus there because it's, although the minus 1 is very small, it means that it's approaching that value from the negative side. It's just less than 2x. Okay, it's just slightly less than 2x. So with that in mind, the x's cancel now. So the limit, if you like, the limit as x tends to infinity is k over 2, but it's approaching from below because I'm sorry, it's approaching from above because the denominator is ever so slightly less than 2x, which means that the equation as a whole is going to be ever so slightly more. It doesn't really matter here anyway, because we're not being asked to sketch the graph. We're just being asked to work out the asymptote effectively. So the asymptote is k over 2. I'm not sure if I explained that very clearly, but effectively, so what this graph is going to look like is, of course, it also depends on whether k is positive or negative, which we don't know. But if we're just for the moment assuming it's positive, then the graph is going to look something like, here's our horizontal asymptote, here is our vertical asymptote, which we know is at a half. So it's going to look something like this. Okay, so the range, it's going to go to plus infinity in this direction, minus infinity in this direction. The only thing it can't be is k over 2. Okay, k over 2 is the value here. So the range is f of x is any real number, except it's not equal to k over 2. All right, sorry, that's a bit messy writing, but that's the range. Okay, that was the, I think almost nobody got that right. And that's a little bit of an unfair question, but there we are, that's what it was. And then the third part of the question is find the inverse function. That should have been more successful than it generally was. So again, so for part triple I, there is a caveat to this as well, though. So for part triple I, as you know, we do y equals the function kx over 2x minus 1. I'll try and do this a little bit quicker. We need to make x the subject. So we multiply up to get rid of the fraction, expand the brackets, collect up x terms on one side, so 2xy minus kx, and the other terms over the other side, factorize out x, and then divide by the bracket, 2y minus k, and then finally swap. So swap x and y gives us y is x over 2x minus k, and therefore that is our inverse function. But there is one caveat, because, as I said, a function is not properly defined unless you also state the domain. And the domain of an inverse function is the same values as the range of the original function. And the range was x, sorry, this is f of x, not x. So f of x is not equal to k over 2. So when we switch that around, that becomes x. So x is not equal to k over 2, which makes a lot of sense, because that is the value that would give us 0 on the denominator, and you can't have zeros on the denominator. So you have to do this to get the final mark. And there have been questions like this on about the last 2 or 3 years of exam papers where they've asked you for an inverse function, and if you don't specify the domain, you don't get the final mark. So do be careful of that. One of my colleagues actually suggested that if you did this part first, because it's much more obvious that this value is excluded from the domain, you then do it in reverse to tell you that that would be the range of the original function, which is an interesting way of doing it. I'm just going to tidy this up. Sorry, this is an absolute mess here. So f of x is in the set of real numbers, but f of x is not equal to k over 2. That's the domain. Sorry, that's the range. Okay, so that was that. We haven't finished yet. We've also got to solve for k, given that f inverse of 2 is 11 over 3g of 2. So, okay, so f inverse, so again, f inverse of 2 is 11 over 3g of 2. Just double checking again. Every time you're turning a page, you're risking introducing an error. So f inverse of 2 is what I now have here. So that is 2 over 4 minus k, which is 11 over 3. And then g of 2, right, g of x, oh gosh, 2 plus 3x minus x squared. 2 plus 3x minus x squared. So that is so 2 over 4 minus k equals 11 over 3 times 2 plus 6 is 8 minus 4 is 4, which is therefore 11 over 12. Multiply out the fractions. We've got 24 equals 11, 4 minus k. 24 is 44 minus 11k. 11k is 20. K is 20 over 11. I think that's it. But a lot of people got that right, which is good. So I think that's the end of question 5.